Hello. So, I thought I was done recording all my AP Physics videos last year. By the way, this is Saturday, September 12th, 2015. A good year for cheese. But I guess I wasn't. I was getting Google Classroom Chapter 4 all situated, and I realized I don't have any sample problems for Chapter 4. So, now's the time for those. Alright, so we'll get right into it. Problem 8 is the first one I want to do. So this chapter, it's been a while since I recorded the actual unit videos for Chapter 4, so there might be a stark difference between those videos in this unit, the first 3 videos, and these, although I am keeping this ugly bluish green background with maroon or reddish font for consistency. I don't know what I was thinking back then. But this Chapter 4 is on 2D motion, and so I got a problem from, at least one problem from each section that you have homework on. That includes average velocity and instantaneous velocity, projectile motion. I actually have a few from projectile motion. We got uniform circular motion, relative motion. Yeah, excuse me. So number 8 is the first one I want to do in your book. This problem is about a plane flying from city A to city B and then from city B to city C. I'll let you read the problem, and we'll just pause the video and then I'll get right into it. Alright, so let's draw a picture. Let's say we'll have plane city A over here. This is city A, and the plane flies this way to city B, and that is 483 kilometers. This takes 45 minutes. Then plane flies south to city C, 966 kilometers and 1.5 hours. And yeah, so that's it. Part A is looking for the displacement. Actually, A and B are together. A is the magnitude of the displacement and B is the direction. So the displacement is your final position, C, minus your initial position, A, and vectorially it is the straight line distance between the two. So we'll just do that. Displacement unknown. This is a right triangle. This is the hypotenuse. So you know that C equals the square root of A squared plus B squared. So we'll just do displacement, we'll say delta, we'll just call delta x, equals the square root of, we'll call this one A, 483 squared plus 966 squared, and that equals 1080.02 kilometers. There we go. So that's the displacement, the magnitude anyway. And the direction, well, we have a bunch of different ways we can represent this, and I want to show all 3 because some of the problems use this east of north or north of east notation, and so I want to sort of explain what that means. So we'll find this angle, theta 1. We'll find this angle, theta 2. And we'll find the unit circle angle, starting from, so you know the unit circle is like 0, 90, 180, 270. So we'll start at, at 0 and go around to this. So we can already tell it's going to be bigger than 270 because it's in the fourth quadrant. Alright, so let's do theta 1 first. Theta 1 equals. Now we have all three sides, so we could use either so, ka, or toa, but let's use toa. So tangent inverse toa, opposite over adjacent. So opposite of theta 1 is 966 over 483. Right, we got to do tan inverse to solve for the angle. In case you forgot your trig. Holy cow, that was a good equal sign for using a tablet. Anyway, this equals. Don't forget I probably mentioned it in the unit videos for chapter 4, but I recorded those, at least 2 or 3 years ago, so I don't remember if I said them or not, said this or not, but make sure in this class that your calculator is in degree mode. You probably have it in radian mode for your math class, most likely. So make sure it's in degree mode, and you should get an angle of 63.43 degrees. Now, let's talk about the notation. This angle goes, so the notation uses north, well, I'll draw another one here, uses these north, south, east, west, and so the angle is going to be relative to one of these 4 perpendicular lines. So in this triangle, the perpendicular line is this one. That's east. So this angle, as you can see, goes south, down south from east. So we say south of east. Theta 2, on the other hand, theta 2, my tablet writing skills are impeccable. Theta 2, we can see the angle starts from the south line and goes over and up east, from east of the south line. So this one is going to be east of south. This is tangent inverse. Now in this case it just flips, right? The opposite of theta 2. I don't have it drawn, but you can imagine down here, this line down here is the opposite, which is the same as this one up here. So 483 over, and then the adjacent one, this vertical one, is the same as this vertical, so 966, and that equals, the other way to do it is just do 90 minus this, because this is a 90-degree angle, right? You know this one, so just subtract 90 from that. But either way is fine. This is a little more work, I guess. 26.57 degrees east of south. The third method, theta 3, you don't need this south of east, east of south. We know it's relative to 0 degrees. This line, east is 0, considered 0, so we'll just give this full big angle, and that'll be it. And the easiest way to do that, we know all all the way around is 360, right? Start here, 0, 90, 180, 270, 360. So we're missing just this little piece right here, this angle from 360. So really all we have to do is subtract 360. Whoa, that was scary. Um, 360 minus theta 1, because this piece missing is theta 1, and that's going to be 296.57 degrees, and we don't need any of that. Alright, what's the average velocity? Part C. Velocity average is the displacement over time. So we got all the pieces We know the displacement up here, 1080. Whoa, you can do it. Come on, 1080.02 over, and then the total time is, the first part is, this is 3/4 of an hour, so 0.75 hours plus 1.5 hours for this trip, part of the trip. And that equals 480 kilometers per hour. What is the direction of the velocity? Well, the velocity, average velocity is along this displacement, so the angle is the same, or the direction is the same as part B, which is all of these. And finally E, what's the average speed? Average speed is distance over time. In this case, the total distance is the path traveled, so that's going to be 483 plus 966. Ugh, horrible. Over the time, this time here, which if you add is 2.25 hours. And that gives us a higher value for the magnitude of the change in position, which is speed or velocity. That's 644 kilometers per hour. Alright, so that was pretty straightforward, but it shows a few things that you'll need. It shows this sort of notation. It shows that displacement is, when you're dealing with two-dimensional motion, it's hypotenuse, right triangle, velocity average is displacement over time, whereas speed is distance over time. So, all right, and the next problem is going to be 18. Talk to you soon. Bye bye.